Welcome. Today we're unlocking something really game-changing, data analytics.
Yeah, it's everywhere now, isn't it?
Think about it, data is just, well, everywhere. Streaming from our phones, our transactions, even sensors in our homes.
Mm,
This sheer volume combined with incredible advancements in computational power has completely revolutionized how decisions are made.
absolutely.
We're moving beyond just gut feelings and anecdotes, really, into a world where intelligence comes straight from the raw information around us.
That's right.
So our mission today is to distill the most important insights from the material we've looked at, giving you a clear, actionable understanding of data analytics, what it is, why it's crucial, and how it's shaping our world.
Sounds good.
So let's unpack this.
All right.
What really defines data analytics? What are we actually talking about here?
Right. Well, at its core, data analytics is really a systematic process.
Okay.
It's about taking raw, often kind of messy data and methodically collecting it, organizing it, transforming it, and then interpreting it. And the goal is always to uncover patterns, trends, correlations, anomalies, things that might otherwise just stay hidden.
Things you wouldn't normally see.
Exactly. And what's fascinating here is that the goal is always to produce actionable knowledge, turning that raw chaos into structured intelligence you can actually use.
Right, making it useful.
Yeah. And, in today's incredibly dynamic economy, extracting timely and relevant insights from data isn't just a competitive edge anymore.
No.
It's become pretty much essential for businesses to even compete effectively. It's how organizations get more agile, reduce uncertainty, and really spark new ideas.
It's fascinating how it moves beyond just, numbers on a page to making real sense of the world.
It really does.
Now, our material breaks data analytics down into 4 distinct but interconnected types. It's almost like a spectrum of understanding, right? From looking backward to peering into the future and even telling us what to do.
Exactly. These 4 types really represent a kind of continuum of analytical maturity. We start with descriptive analytics, which is the foundational tier. Okay, the starting point.
Right. It's about painting a crystal clear picture of what has happened. It's like being a meticulous historian, sifting through every piece of data to find the hidden narratives.
Gotcha.
So for instance, if you're looking at past quarterly revenue streams, descriptive analytics can instantly reveal seasonal fluctuations or maybe long-term growth trends.
Ah, okay.
Tools like Microsoft Excel for quick insights, or things like Tableau and Power BI for creating these visually stunning interactive dashboards, they're perfect for making these trends immediately obvious to anyone.
So descriptive tells us what happened, but that doesn't necessarily tell us why. That's where the next stage comes in, right? How do we get to that deeper understanding?
Precisely. That leads us straight to diagnostic analytics. This builds directly on those descriptive insights by digging into the underlying causes of whatever outcomes you observed.
Okay.
It answers the question, why did it happen? So if those product sales suddenly dropped, like in your example.
Yeah. Diagnostic analytics would delve deeper.
Mm,
You would explore factors like maybe changes in pricing, shifts in customer behavior, competitor actions, or even, external economic conditions.
right. All the potential reasons.
Exactly. By isolating these causal variables, organizations can pinpoint exactly what went wrong or, just as importantly, what went right.
And from understanding the past, we then make that incredible leap into forecasting the future, which, that feels incredibly powerful.
That's predictive analytics. And yeah, it is powerful. This shifts the focus entirely to anticipating future outcomes using historical data, statistical models, machine learning, all that good stuff.
Right.
It asks the question, what will happen? A really standout example from the material is forecasting customer churn.
Okay, like when customers leave.
Exactly. By identifying subtle behavioral indicators, maybe declining engagement or reduced purchase frequency models, can predict which customers are likely to discontinue service. And what's transformative here is that it fundamentally shifts a company from a reactive lose and acquire model to a proactive nurture and retain philosophy.
Yeah.
It helps foster deeper customer relationships.
That's amazing being able to sort of see around the corner like that. But then the highest level really pushes it further, doesn't it? Moving from just predicting to actually prescribing action.
Yes, that's prescriptive analytics.
Yeah.
This is the highest level of analytical complexity. It goes beyond just forecasting to actually recommending specific courses of action based on those predictive outcomes.
So it tells you what to do.
Pretty much. It answers, what should we do about it? For a retail company, for example, prescriptive analytics might determine the optimal inventory replenishment schedule across multiple store locations, factoring in forecasted demand, logistics constraints, maybe even supplier lead times. These tools are like decision-making superpowers, helping evaluate trade-offs and select the best strategies, even when things are uncertain. It's about truly guiding action.
It's truly fascinating how it progresses from just understanding the past to actively shaping the future. Now let's connect these dots. How does all this analytical horsepower actually translate into tangible strategic advantages, things that can really make or break an organization?
Yeah, you've hit on the core point there.
Mhm.
The material frames data analytics as a genuinely transformative capability.
Mhm.
It enables organizations to shift from being purely reactive
Yay.
to becoming proactive and even preemptive in their operations.
Okay.
Think of it this way. Companies that embed data analytics across their strategic and operational layers, well, they consistently outperform competitors in efficiency, innovation, customer engagement,
Hmm.
you name it.
So it's a real differentiator.
Absolutely.
Yeah.
They treat data not as some kind of byproduct, but as their most valuable strategic asset.
And our material highlights 4 incredible ways this plays out. Let's walk through them.
Sure.
First, enhanced operational efficiency. Data analytics helps pinpoint inefficiencies, right? Redundancies, underperforming processes, stuff like that. Imagine a manufacturing firm using sensor data to predict when equipment might fail. That allows for timely maintenance and dramatically reduces costly downtime.
Yeah, that's a classic example.
Or in complex supply chains, analytics enables dynamic routing and inventory optimization, leading to leaner operations and, significant cost savings. It's about making everything run smoother, faster, and smarter.
Precisely. And building right on that, we have improved customer insights.
Ah, customer piece, always crucial.
In today's hyper-personalized world, yeah, understanding customer behavior is paramount. Data analytics allows organizations to capture, segment, and analyze just vast amounts of behavioral, transactional, demographic data.
Getting that full picture.
Exactly. Creating a multi-dimensional view of the entire customer journey. Techniques like customer lifetime value modeling, which predicts the total revenue a customer will generate over time, sentiment analysis, which helps understand the emotional tone of customer feedback, and recommendation engines, suggesting products or content based on past behavior and preferences.
Like on streaming sites.
Perfect example. All these empower businesses to tailor their offerings and communications with incredible precision, and that ultimately boosts satisfaction, loyalty, and retention.
This also extends to protecting the organization, right? Which brings us to risk mitigation and resilience. How does data help there? What's a kind of what-if scenario that analytics helps prevent?
Oh, it's crucial here. Predictive analytics and anomaly detection algorithms can uncover potential threats before they escalate.
Before they become big problems.
Exactly. Imagine a financial institution using it to flag suspicious transactions in real time, preventing fraud before it even happens,
Wow.
or detecting a cyber attack in its earliest stages. In banking and insurance, real-time data streams and historical modeling assist in accurate credit scoring, claims analysis, compliance monitoring.
All vital stuff.
Definitely. And analytics also enhances organizational resilience by enabling sophisticated scenario planning and stress testing, which are just vital in our rapidly changing global environment.
And finally, it's not just about protecting, it's about growing and evolving too. What's a surprising innovation that, maybe only happened because of data?
Right. That's fostering innovation and strategic agility. Data analytics acts as a powerful catalyst for spotting new opportunities.
How so?
Well, by analyzing emerging patterns in consumer behavior, market conditions, competitive activity organizations can identify new niches or anticipate shifts in demand way ahead of time.
Okay.
Think about how streaming services continuously refine their content recommendations based on viewing data. That can lead to entirely new show genres being developed.
Ah, interesting.
Or how smart city planners use traffic data to optimize infrastructure projects. In tech, usage data informs the iterative development of digital products, constantly improving user experience and accelerating time to market.
So it's a cycle.
It is, and these advantages aren't isolated. They really build on each other to create a powerful, sustainable, competitive edge.
That's a powerful overview of the strategic impact. Let's maybe bring this to life with some specific examples. The material showcases the sheer versatility of data analytics across a whole broad array of industries.
Certainly. In healthcare, for instance, data analytics has really ushered in an era of evidence-based medicine.
Okay.
Predictive models are widely used to anticipate things like patient readmissions, detect early signs of deterioration, and personalize treatment plans.
Personalized treatments. How?
Well, for example, Machine learning algorithms can analyze electronic health records and vital signs to identify patients at high risk of conditions like sepsis much earlier than might otherwise be possible.
That's incredible. Saves lives.
It can, yeah. And it not only improves clinical outcomes, but also helps manage healthcare costs more efficiently.
And in finance, where data is obviously king, it must be equally transformative.
Oh, absolutely. In the financial sector, real-time data analytics is just critical for risk management and fraud detection.
Real time is key there, I bet.
Definitely.
Hmm.
Think about high-frequency trading platforms. Algorithms execute millions of trades in milliseconds based on real-time data. They rely on analytics for their very existence.
Wow.
Banks and insurance firms use anomaly detection constantly to flag suspicious transactions or claims immediately. Credit scoring models are constantly refined by sophisticated analytical techniques, enhancing predictive accuracy and, ideally, fairness too. It's an indispensable tool for maintaining security and integrity.
It's also making a real difference in the public sector, isn't it? Which affects all of us.
Indeed. In the public sector and governance, governments and public agencies are increasingly using data analytics to improve policymaking and allocate resources more effectively.
Like how?
Well, educational analytics, for example, can inform curriculum reforms based on analyzes student performance data over time.
Okay.
Predictive policing models, though controversial, aim to help law enforcement allocate resources to high-risk areas and during public health crises, like the recent COVID-19 pandemic.
Yeah, that was huge.
Analytics was absolutely instrumental in epidemiological modeling, tracking the spread, resource allocation,
Yeah.
literally helping to manage outbreaks and save lives.
It's clear the applications are just endless, really, but none of this runs itself right. You need the right tools and, crucially, the right people.
That's a critical point. Successful execution of data analytics relies heavily on selecting and effectively using the appropriate tools. The material categorizes them into several types.
Okay.
So for descriptive and visualization needs, you have accessible tools like Microsoft Excel or Power BI, great for quick summaries and those interactive dashboards we mentioned.
Right, the basics.
Then, for more complex analytical tasks like predictive modeling or machine learning, you typically see statistical and programming environments like R and Python. Data scientists favor these for their incredible flexibility and scalability.
The heavy lifting tools.
Exactly. Then there are data management systems. Things like SQL-based systems for structured data or NoSQL databases like MongoDB, which are designed to handle data that doesn't fit neatly into traditional rows and columns. Think social media posts or sensor readings.
Right, the unstructured stuff.
Precisely.
And of course, the cloud has changed everything here, hasn't it?
Absolutely. Cloud-based analytics platforms, AWS, Azure, Google Cloud, they offer scalable, flexible, and often cost-efficient infrastructures for handling vast amounts of data and complex analyses.
Makes it more accessible.
It does. These platforms provide high availability parallel processing. They're really suitable for organizations dealing with high velocity, high volume data on a global scale.
So, okay, that's the tech side. What does this all mean for you, the professional, listening in this evolving landscape? The material really underlines the vital skill of data literacy.
Data literacy is truly becoming a foundational professional competency now across pretty much all industries. It basically refers to the ability to read, work with, analyze, and argue with data effectively.
Read, work with, analyze, argue.
Yeah.
Okay.
The material breaks it down into 4 key components. First, quantitative reasoning. This is about spotting the story in the numbers, not just, reading them off a page.
Understanding what they mean.
Right. It's the ability to apply statistical methods, understand distributions, interpret findings effectively.
So understanding the numbers themselves, what about the underlying systems? How the data gets there?
That's data engineering literacy. It's having a working understanding of the plumbing, essentially how data is collected, stored, retrieved.
Okay.
So some familiarity with data formats, maybe query languages like SQL, and the principles of data security and privacy. Even if you're not writing the code yourself, a conceptual grasp of data pipelines and quality control is essential. You need to trust the data your insights are based on.
Right, knowing it's reliable. Then comes the thinking part, I guess. Data doesn't just speak for itself, does it?
Exactly right. That's critical analysis and contextual understanding. Data can lie, or at least mislead if you're not careful. Well, a data literate professional recognizes potential biases in data. They question the assumptions behind the models being used, and they understand how findings fit into the broader context.
Gotcha.
For instance, a marketing analyst needs to consider how seasonality or maybe an economic downturn might influence sales data, not just look at the raw figures in isolation.
Makes sense. And finally, what do you do with all those insights? How do you make them actually, well, stick?
That brings us to communication and data storytelling. And this is perhaps the most vital, yet often the most underappreciated, competency.
Really? Why is that?
Because it's about translating complex findings into clear, persuasive narratives. It's about creating compelling visualizations and actionable recommendations, especially for non-technical stakeholders.
Bridging that gap.
Precisely. Effective data storytelling bridges the gap between the analysis and the action. It ensures that insights are not just understood, but are actually applied in decision-making processes. Otherwise, it's just numbers on a report.
This raises a really important question, though. With all this power that data gives us, what about the responsibility that comes with it?
Absolutely crucial. The material makes it very clear that while data offers immense power, it also brings significant ethical responsibilities and regulatory challenges.
Like what?
Well, take data protection, for example.
Yeah.
We're talking about legal frameworks like GDPR in Europe or CCPA here in California, POPI in South Africa.
Right, the regulations.
Exactly.
Mhm.
And these aren't just bureaucratic hurdles. They're fundamentally about ensuring privacy, transparency, and giving individuals control over their own information. It's really about building trust and protecting people's personal data, not just ticking legal boxes.
And the idea of algorithms being unfair, that's a major societal concern right now.
It absolutely is, and that leads us directly to algorithmic bias.
Hmm.
Imagine an AI being used for hiring decisions,
Okay.
and it's trained on historical data where certain demographics were unknowingly or maybe knowingly favored or discriminated against in the past.
Hmm.
That AI might then just perpetuate those same biases.
So it learns the bad habits.
Exactly. It can lead to systemic discrimination. That's why fairness, accountability, and transparency in model design are so incredibly vital, especially